And yes, infrastructure tools has always been something very unique, I would say. There are some innovations there about introducing software, but cloud brings the whole game into totally different level. You can program many things right on the cloud. You mentioned in one of your blog that cloud is actually now a first-class application architecture concern. So tell us more about this term, first-class application architecture concern.
Yeah, so another part of my background in the 2000s, I worked on multi-core and parallel programming and bringing async into all these languages. So now you have async await. Back then, we didn't have that. So we created a task framework in .NET. And this honestly led to async await in .NET. Now you see that in every language, right? This concept. But nobody had done a similar thing for cloud. I actually worked on a distributed operating system while I was at Microsoft. And this was before containers, but it was really about how do we build large scale distributed applications? How do we configure them? How do these different services talk to each other? And funny enough, that was like 10 years before we founded Pulumi. And a lot of the same patterns recur where if you take a step back, we're really in the cloud, we're building distributed applications. It's now finally, we've been talking about it in research for 50 plus years. We're finally at the age of distributed programming. And the companies that are most successful getting the most out of the cloud that are building amazing things. You think about Uber, Spotify, AWS themselves, they embrace the fact that this distributed application architecture is now a first-class thing that we can incorporate into our applications. You don't get there by treating the cloud as a collection of virtual machines. You get there by really thinking about these application patterns. And that's what I meant by that. How do we connect these different systems? How do they speak to each other? Back in the early days, we called that service discovery. We had enterprise service buses and like all this stuff with J2EE. It's like very similar patterns, just sort of cast in a new light.
Yeah. And the follow-up thing that you mentioned, which I found very interesting in your blog, you mentioned with all these distributed apps coming, cloud with its own technologies, not just providing infrastructure, CPU, memory, and all that, but also more new products, things like containers, serverless, and things like that. You mentioned that now cloud has become like a giant supercomputer. So maybe it's interesting to dig deeper here. Why do you think cloud is a giant supercomputer? How do you get the analogy from?
Yeah, the funny thing is you think about what is an operating system and you think about how do you interact with your operating system in typical programming models. Think about back in the day with C and C++, you're programming directly to the operating system's API. And then over time, we came up with Node.js and Ruby and more productive ways of programming, and they sort of abstract away a little bit of the operating system. But really, the operating system is all about controlling access to hardware and scheduling operations against that hardware. That's the job of an operating system. Well, what is the role of the cloud? The role of the cloud is it's a piece of software that manages a lot of different hardware and controls access to it and schedules access against it. And so if you use that analogy, we're sort of missing that Node.js of the cloud. We're missing these higher level abstractions. In fact, we're sort of still in the days of C, maybe even assembly, but let's give a little bit of benefit of the doubt. It's more like C, but what are those higher level programming model concepts that we're sort of missing today? And I think a lot of folks talk about Kubernetes. I think of Kubernetes as it's really just the kernel scheduler or the thread scheduler for the cloud, but it doesn't stop there. There's so much more to be built on top of that foundation. The exciting thing is we've now at least agreed on some of the foundational pieces like, hey, Kubernetes is probably here to stay. And we know how to schedule containers. And so now we can build these higher level services. Although Pulumi lays this great programmable foundation, I think the next phase is what are these higher level experiences that have yet to be built?
When you mentioned Kubernetes, I mean, it all started for scheduling like containers and things like that. While in the cloud, there are still so many other things like the VMs, the serverless, the databases and things like that. So yeah, there's a little bit of mismatch, although people are trying to Kubernetesify everything, I guess.
Right.
That's the term. Yeah. So we'll talk about that later as well. But yeah, you mentioned about this giant operating system, right? It's like cloud is an operating system where you have so many infrastructure, these hardwares that you can use, and you have to build some kind of layers to control all of them. Which brings back to the next topic, which is the cloud engineering. So with all these needs, all these resources available, you mentioned that there is probably more things that we can do in order to help people to build on top of the cloud. And you mentioned this term called cloud engineering. Why is cloud is another kind of like discipline within engineering? What is cloud engineering? Maybe you can tell us more about that.
Yeah, I think we're starting to see this term used a lot more broadly, but to us, cloud engineering is a few things. One, bringing the cloud closer to application developers so that cloud is part of the software engineering process. Two, bringing software engineering tools and techniques to infrastructure teams to help tame some of the complexity of the modern cloud. And really, all this ties into what we were just talking about, which is how do you program the supercomputer? Well, you do it with software engineering techniques. We don't think of it as an afterthought or something that is lots of copy and paste. We think that really bringing to bear all the decades of improvements in software engineering applies just as much to the cloud as it does to regular application development on classic operating systems. And then by doing the first two things, we do the third thing, which is really help break down the barrier between developers and infrastructure teams so we can just collaborate on equal footing to just build great software together. And to us, that's cloud engineering. You can think of it as the evolution of what comes after DevOps. In many ways, DevOps was more about bringing some dev techniques to ops teams, but not as much the opposite, which is really having developers thinking about the cloud as part of the application architecture. And I think you need to do both in order for that cross-pollination to happen. At least that's what we're seeing.
So it's very interesting that you mentioned this is like the next phase of DevOps, or maybe it's just another flavor of DevOps, right? DevOps itself is like, people say it's mindset, culture, where developers and operations people work together very closely. It could be borrowing each other's techniques. But I think cloud engineering maybe is like a special flavor of the DevOps or the next stage of DevOps, where you use the power of the cloud to bring the devs and the ops closer together.